July 9th, 1944. Aslito Airfield, Saipan. Lieutenant Commander Tadashi Nakajima stood in the tropical morning heat, staring at the impossible. Sitting on the pierced steel planking, barely damaged, its dark blue paint shimmering in the Pacific sun, was an F6F Hellcat, Bureau number 66237, the aircraft that had killed more Japanese pilots than any other weapon in history. Around him, mechanics and pilots from the 343rd Naval Air Group gathered in silence. For 18 months, they had fought this fighter, watched friends die under its 6 terrible guns, fled from its vertical climbs, failed to escape its diving attacks. Now one sat before them, intact, waiting to reveal its secrets. "How did we capture it?" Nakajima asked Captain Yoshio Shiga, the base commander. "We didn't capture it," Shiga replied. The pilot landed, thinking he was on Tinian, realized his mistake too late. "He destroyed the radio and gunsight before we could reach him, but the rest is perfect, fully armed, fully fueled. The maintenance officer says it can fly." Nakajima circled the aircraft slowly, notebook in hand. The Hellcat sat low and wide, its landing gear splayed like a wrestler's stance. Compared to the elegant Zero, it looked brutal, purposeful, designed by engineers who valued function over form. The numbers painted on captured aircraft were familiar from intelligence reports. Length, 33 feet 7 inches. Wingspan, 42 feet 10 inches. Height, 13 feet 1 inch. But seeing it in person made those numbers tangible in a way reports couldn't convey. "It's enormous," said Lieutenant Saburo Kitahata, one of the few pilots present with more than 500 combat hours. "The fuselage alone is wider than a Zero's entire wingspan at some points." Nakajima climbed onto the wing. The construction was crude by Japanese standards. Rivets protruded everywhere. Panels fit together with gaps that would horrify Mitsubishi quality inspectors. But as his hand ran across the metal skin, he understood. This wasn't crude construction. It was expedient construction. Every component designed for rapid assembly by semi-skilled workers. The cockpit access was his first shock. Instead of climbing onto the fuselage and lowering himself in, he simply opened a massive door and stepped into the cockpit as if entering a car. The interior was cramped despite the aircraft's size, every cubic inch occupied by equipment, armor, or structure. "There's a steel plate behind my back," Nakajima called down. "And another under my seat, and more around my head." He rapped his knuckles against the metal. "Each piece is at least 8 millimeters thick. The pilot sits in a steel box." Warrant Officer Kiyoshi Ito, the group's senior maintenance officer, climbed up beside him. The fuel tanks are self-sealing, 3 layers of rubber with a vulcanizing layer between. American reports say they can take up to 40 hits from 7.7 millimeters rounds without significant fuel loss. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The instrument panel overwhelmed Nakajima. A Zero's cockpit contained perhaps 20 instruments. The Hellcat had over 40, arranged in a logical layout that seemed designed for nighttime reference. Everything was placarded in English. Throttle markings, mixture settings, propeller pitch, radio frequencies. "The radio," Nakajima said, examining the SCR 274 Newton set. "It has 4 channels, not 1. And this switch bank," he counted quickly, 18 switches for electrical systems. The Zero has 3. Ito was already opening panels, revealing the aircraft's internal structure. What he found contradicted everything Japanese engineers had been taught about aircraft design. "Look at this hydraulic system," Ito said, his voice carrying a mix of admiration and horror. "The landing gear, wing folding, flaps, cowl flaps, all powered by a central hydraulic system with redundant lines. If one line is damaged, another takes over. In a Zero, everything is manual or electric, simple but vulnerable. The armament installation was Nakajima's primary interest. 6 Browning M2. 50 caliber machine guns, 3 in each wing. He had faced these guns in combat, watched their tracers converge on wingmen who exploded under their impact. Now he could examine them directly. Each gun was mounted in a steel cradle, belt-fed from ammunition boxes buried deep in the wing. The installation was industrial, brutal, effective. No attempt at elegance, just 6 identical weapons placed where convergence mathematics dictated maximum effectiveness. 400 rounds per gun, Ito noted, checking the ammunition boxes. 2,400 rounds total. At 750 rounds per minute, that's approximately 20 seconds of continuous fire. But American doctrine calls for 2-second bursts. Nakajima did the math quickly. 60 bursts. In combat, that's 60 separate firing opportunities. A Zero has about 15 bursts before ammunition exhaustion. The true revelation came when they examined the ammunition itself. Ito opened one of the 50 caliber cans and extracted a single round. The brass cartridge gleamed, professionally manufactured, identical to every other round. He pulled several more. Each one was indistinguishable from the others. Every 5th round is a tracer, Ito observed, examining the sequence. Then 1 armor-piercing incendiary, then 3 standard ball rounds. The pattern repeats perfectly through all 2,400 rounds. He held up a single 50 caliber bullet next to a 7.7 mm round from a Zero. The comparison was stark. The American bullet was twice the diameter, 3 times the weight, contained 4 times the powder charge. The kinetic energy of a single 50 caliber bullet is approximately 18,000 joules at muzzle velocity, Ito calculated. 6 guns firing simultaneously deliver 108,000 joules per trigger pull. A Zero's 2 7.7 mm guns deliver perhaps 4,000 joules combined. Lieutenant Kitahata, who had been examining the wings, called out, 2,000 Zapa. The wing construction, come look at this. They joined him where he had removed an access panel. The Hellcat's wing spar was a single piece of forged steel, running continuously from tip to tip, passing through the fuselage. Around this main spar, ribs and stringers formed the wing's shape, covered by a stressed aluminum skin. This spar alone could support the entire aircraft, Kitahata said. The rest of the wing is just for aerodynamics. In a Zero, the wing structure and the strength are integrated, lighter but vulnerable. This is redundant by design. Ito pointed to the wing's leading edge. Ammunition storage here, fuel tanks here, guns here. Everything is placed outboard of the fold point. If a wing is damaged and must be replaced, the entire armament system goes with it. Modular design. Any Hellcat wing can fit any Hellcat fuselage. The landing gear mechanism revealed. More American design philosophy. Massive steel struts that retracted backward into the wings, each with a hydraulic shock absorber the size of a Zero's entire landing gear leg. Watch this, Ito said, activating the hydraulic pump. The landing gear extended and retracted smoothly, locks engaging with heavy clunks. 17 seconds full cycle. A Zero takes 30 seconds and requires 30 cranks of the hand pump. American pilots just flip a switch. The engine was the crown jewel of their investigation. The Pratt & Whitney R2800 double wasp radial engine, 2,000 horsepower, 18 cylinders arranged in 2 rows. Nakajima and Ito spent an hour examining it before either spoke. Every part is interchangeable, Ito finally said. This engine was built in Hartford, Connecticut, but any R2800 from any factory can replace it. Same mounting points, same connections, same everything. He showed Nakajima the engine logbook, recovered from the cockpit. This engine has 273 hours. It's rated for 1,000 hours between overhauls. The Nakajima Sakai in a Zero requires overhaul every 400 hours, and that's theoretical. Most need work at 250 hours. The supercharger system was particularly sophisticated. 2-stage, 2-speed, with automatic controls that selected the optimal gear ratio based on altitude. The pilot simply advanced the throttle. The engine handled everything else. Our pilots must manually lean the mixture, adjust the prop pitch, monitor the engine constantly, Nakajima noted. This pilot just flies. The engine manages itself. They found the instruction manual in a waterproof pouch. Pilot's Handbook of Flight Operating Instructions for Navy Model F6F airplane. It was 200 pages of detailed procedures, performance charts, and emergency protocols, more comprehensive than the documentation for an entire Japanese air group. One section caught Nakajima's attention: combat tactics and enemy aircraft comparison. Detailed performance data, strengths, weaknesses, and recommended engagement tactics. The Americans knew their enemy better than the Japanese knew themselves. The radar detection equipment, the IFF transponder, the radio compass, the artificial horizon, the directional gyro, every instrument represented technology the Japanese either didn't have or couldn't produce in quantity. The Hellcat wasn't just an aircraft, it was a flying electronics laboratory. By afternoon, they had completed their initial assessment. Nakajima gathered the pilots and mechanics in the operations tent, his notebook filled with observations that would change everything. This aircraft weighs 12,186 pounds loaded, he began. Our intelligence was correct. It is twice the weight of a Zero. What intelligence failed to convey is why. He held up his notebook. The armor plating weighs 212 pounds. The self-sealing fuel tanks add 140 pounds. The 6 50 caliber guns and 2,400 rounds weigh 1,020 pounds. The additional radio equipment, 60 pounds. The radar, 35 pounds. The extra structural strength to handle 13 G loads, approximately 400 pounds. Every pound has a purpose, he continued. The Americans didn't make it heavy through ignorance. They made it heavy through philosophy. They designed an aircraft that brings its pilot home. Lieutenant Kitahata asked the question everyone was thinking. Can we fly it? We can, Nakajima replied. And we will. Tomorrow morning, I will take it up. We need to understand not just what it is, but what it can do. That evening, as the sun set over Saipan, Nakajima wrote his preliminary report for Combined Fleet Headquarters. His conclusion would prove prophetic. The F6F Hellcat is not a fighter aircraft in the traditional sense. It is a weapons platform, designed to deliver overwhelming firepower with minimal risk to the pilot. Every aspect of its design prioritizes pilot survival and mission completion. Our Zero prioritizes performance. The Hellcat prioritizes results. In warfare, results matter more than elegance. We have been outthought, not just outbuilt. The next morning would reveal whether the Hellcat's performance matched its impressive specifications, but Nakajima already knew the fundamental truth. They had been fighting not an aircraft but a system, and systems designed by America's industrial might were proving impossible to defeat with warrior spirit alone. The captured Hellcat sat on Aslito Airfield, its secrets partially revealed. Within 24 hours, it would reveal its most important secret. In the air, it was even more formidable than on the ground. July 10th, 1944. 0600 hours. Aslito Airfield. Lieutenant Commander Tadashi Nakajima completed his pre-flight inspection of the captured Hellcat as the first light of dawn illuminated the Pacific. Around him, every pilot and mechanic from the 343rd Naval Air Group had gathered to witness what might be the most important test flight of the Pacific War. Warrant Officer Ito had spent the night ensuring the Hellcat was fully operational. Fresh fuel, hydraulics checked, all 6 guns loaded with 400 rounds each. The only modifications were Japanese markings hastily painted over the American stars to prevent friendly fire incidents. The engine should start easily, Ito briefed. 6 shots of primer, mixture rich, throttle 1 inch open, magnetos both, and hit the starter. The R2800 is known for reliable starting. Nakajima climbed into the cockpit, his movements careful. The layout was logical once you understood American thinking. Everything grouped by function. Engine controls on the left, flight controls center, radio right, landing gear and flaps below. He ran through the checklist printed on a card bolted to the panel. 47 items before engine start. A Zero had 12, but each Hellcat checklist item was simple, binary, switch on or off, lever forward or back, no calculations required, no manual adjustments. The aircraft managed its own complexity. The starter engaged with a whine. The massive propeller rotated slowly, once, twice. Then the R2800 caught with a roar that shook the entire aircraft. Nakajima felt the engine's power through the airframe. 2,000 horses, more power than any Japanese production aircraft could generate. The engine note was rough compared to a Sakai's smooth purr. The exhaust smell was different, richer, heavier with oil and unburned fuel. But the gauges all showed normal, oil pressure rising, cylinder head temperatures climbing evenly. The engine was running exactly as designed. Nakajima advanced the throttle slightly. The Hellcat rolled forward, initially reluctant, then gaining momentum. The visibility over the nose was terrible. He had to S-turn down the taxiway to see ahead. A Zero pilot sat high with excellent visibility. A Hellcat pilot sat low in his steel cocoon, seeing the world through a gunsight. At the runway threshold, he completed the before takeoff checklist. 19 items. Trim tabs set, flaps 20 degrees, prop full forward, mixture auto rich, cowl flaps open, fuel selector main tank, every switch verified. He keyed the radio, speaking in Japanese. Hellcat taking runway. Standing by. From the tower, Captain Shiga responded. Cleared for takeoff. All other aircraft hold position. Make 1 circuit and return. Do not engage in aerobatics on first flight. Nakajima aligned with the runway centerline and smoothly advanced the throttle. The R2800's response was immediate and overwhelming. The Hellcat accelerated like nothing he had ever flown. The tail came up at 30 knots. The main gear left the ground at 75 knots, barely 8 seconds after starting the takeoff roll. A Zero needed 14 seconds to reach rotation speed. The Hellcat simply muscled into the air through raw power, climbing at 2,500 feet per minute immediately after liftoff. Nakajima was at 1,000 feet before reaching the end of the runway. The first surprise was the smoothness. Despite the power, despite the weight, the Hellcat flew with surprising refinement. Control forces were heavy compared to a Zero. No manual muscle could wrench this aircraft around the sky, but perfectly harmonized. The ailerons required specific force. The elevator required exactly twice that force. The rudder required half. This coordination made the aircraft fly naturally despite its size. At 5,000 feet, Nakajima leveled off and began his evaluation. First, straight and level flight. He trimmed the aircraft carefully. Once set, the Hellcat flew hands-off, maintaining altitude and heading precisely. A Zero required constant minor corrections. The Hellcat simply flew where pointed. He checked the airspeed, indicating 180 knots at 2,000 revolutions per minute and 32 inches of manifold pressure. Cruise power. The engine note was steady, mechanical, relentless. Fuel consumption was showing 80 gallons per hour. Heavy by Japanese standards, but the Hellcat carried 250 gallons internal. Over 3 hours of endurance at cruise. Beginning handling tests, he reported. The gentle bank came first. He rolled into a 30-degree bank and held it. The Hellcat maintained altitude without back pressure, naturally coordinating the turn. Japanese fighters required elevator input in turns. The Hellcat's design anticipated the pilot's needs. He tightened the turn to 45 degrees, then 60. At 60 degrees, the stall warning buffet began at 110 knots. He maintained the turn, feeling the airframe vibrate gently. The stall, when it came, was benign. The nose dropped slightly, the wings stayed level, and forward stick immediately recovered flying speed. No snap, no spin tendency. The Hellcat wanted to fly. Nakajima tried a Zero's favorite maneuver, the maximum rate turn. He rolled to 75 degrees of bank and pulled back firmly. The G-meter showed 5 Gs. The airspeed bled from 180 to 140 knots. The turn rate was respectable, perhaps 18 degrees per second, but the energy loss was catastrophic. After one complete turn, he was down to 120 knots and struggling to maintain altitude. "The turn rate is inferior to 0, he reported, but the structural integrity is absolute. I pulled 5 Gs with no airframe stress indications. Maximum 0G limit is 4.5. The American pilot can turn harder without breaking his aircraft." Recovery from the slow-speed turn revealed the Hellcat's genius. He simply lowered the nose 10 degrees and advanced to full throttle. The R-2800, which had been loafing at cruise power, unleashed its full 2,000 horsepower. The acceleration was breathtaking, from 120 knots to 200 knots in 12 seconds. The energy he had lost in turning was instantly regained. "A Zero cannot do this." Nakajima spoke into the radio, his voice carrying both admiration and dread. "If a Zero bleeds speed in combat, recovery takes 30 seconds minimum. The Hellcat recovers energy in half that time. The American pilot can make a mistake and recover. We cannot." He climbed to 10,000 feet to test high-altitude performance. The R-2800's two-stage supercharger automatically shifted to high gear at 8,000 feet. He felt the engine note change, heard the supercharger whine increase. The rate of climb, which had been dropping as he climbed, suddenly increased again. At 10,000 feet, the Hellcat was still climbing at 2,200 feet per minute. A Zero at this altitude climbed at perhaps 1,500 feet per minute. The power advantage was overwhelming. He continued to 20,000 feet. At this altitude, where Japanese fighters struggled, the Hellcat remained potent. The engine was still producing over 1,600 horsepower. The controls remained responsive. The climb rate was still over 1,000 feet per minute. "The altitude advantage is decisive," he reported. At 20,000 feet, this aircraft performs better than a Zero at 10,000 feet. American pilots can choose the altitude of engagement. We cannot force them to fight low where our maneuverability advantage exists. Preparing and narrating this, the story took us a lot of time, so if you are enjoying it, like this video, it means a lot to us. Now back to the story. The dive test came next. From 20,000 feet, Nakajima rolled inverted and pulled through to vertical. The Hellcat accelerated downward, the airspeed indicator winding through 200, 250, 300 knots. At 350 knots, he started a 4G pullout. The Zero's maximum dive speed was 360 knots before structural failure. The Hellcat was stressed to 475 knots. More importantly, the controls remained effective at high speed. The ailerons still rolled the aircraft. The elevator still pitched. A Zero's controls began to stiffen at 280 knots and became nearly immovable by 330 knots. In a dive, the Hellcat dominates completely. Nakajima continued his running commentary. "We cannot dive away from it. We cannot catch it in a dive. The speed range where we can fight is 140 to 280 knots. The Hellcat's range is 120 to 400 knots. They control the energy state of every engagement." He climbed back to 15,000 feet for the weapons test. The armament officer had loaded one gun with 50 rounds for initial firing trials. Nakajima selected a cloud as a target, aligned the gunsight's illuminated reticle, and pressed the trigger. The single 50 caliber gun hammered, the vibration different from a Zero's 7.7mm weapons. Deeper, more violent. The tracers arced outward, each round visible as a streak of fire. In 2 seconds, the gun had fired 25 rounds. He released the trigger and examined the results. 1 gun, 2-second burst, visible hits on cloud formation, he reported. The recoil is negligible. The gunsight tracks perfectly, now testing full armament. He aligned on another cloud formation, larger and denser. 6 guns loaded, 2,400 rounds ready. He pressed the trigger. The Hellcat vibrated as 6 machine guns fired simultaneously. The sound was overwhelming even through his flight helmet. The tracer pattern converged ahead of the aircraft, every 5th round visible, creating a cone of fire that seemed to fill the entire sky. He held the trigger for 3 seconds. 1,800 rounds fired, 150 from each gun. The cloud formation simply disintegrated, shredded by the concentration of fire. "Gunnery test complete," Nakajima said, his voice quiet. "The firepower is beyond anything we face. A 3-second burst delivers enough bullets to destroy any aircraft. The American pilot does not need to be accurate. The volume of fire compensates for minor aiming errors." He descended to low altitude for the final test, combat maneuvering. At 5,000 feet and 200 knots, he simulated engaging a Zero. Hard turn. The Hellcat turned adequately but lost energy. The Zero would have an advantage. But then what? He pushed forward, diving to rebuild speed, then pulled up in a vertical climb. The Hellcat went straight up, passing through 8,000 feet before momentum was exhausted. At the apex, he kicked the rudder and let the aircraft fall onto a new heading. A hammerhead. Turn. The vertical maneuverability negates the Zero's turn advantage, he continued. When we turn to engage, the Hellcat goes vertical and attacks from above. Our superior turn rate becomes irrelevant. We are fighting in 2 dimensions. They fight in 3. 1 final test remained. The guns. He had fired them in level flight, but combat happened in high G turns, in dives, in climbs. He rolled into a 4G turn and fired a burst. The guns tracked perfectly, the vibration no worse than in level flight. He rolled inverted and fired. Same result. Negative G, positive G, sideways the Browning M2S fired reliably in every attitude. "Armament reliability is absolute," he reported. "Japanese guns jam in negative G maneuvers. These do not. The Hellcat pilot can shoot while maneuvering. We must stabilize before firing, another advantage to them." After 45 minutes airborne, Nakajima entered the landing pattern. The approach was stable, the Hellcat settling onto the glider path with minimal adjustment. At 85 knots, he crossed the runway threshold and smoothly reduced power. The Hellcat settled onto the main gear, then the tail, rolling straight with no tendency to ground loop. He taxied back to the parking area, where the entire group waited. When he shut down the engine and climbed out, the silence was profound. Captain Shiga approached. "Your assessment?" Nakajima closed his notebook. "The F6F Hellcat is unbeatable within its designed mission. It does not turn with us because it does not need to. It controls the altitude, the speed, the range of engagement. Every time we fight on our terms, using our advantages, the Hellcat changes the terms. It has no weaknesses we can exploit because the Americans designed around our tactics." He paused, choosing his words carefully. "More significantly, the ease of operation means average American pilots can be effective. This aircraft compensates for pilot inexperience. It protects them from their mistakes. It amplifies their strengths while minimizing their weaknesses. In a Zero, only an expert survives. In a Hellcat, even a novice has a chance." Lieutenant Kitahata asked the question no one wanted to voice. "Can we defeat it?" In theory, yes, Nakajima replied. If we force low-speed turning combat and maintain perfect energy management, a highly skilled pilot in a Zero can prevail. But combat is not theoretical. The Hellcat pilot decides whether to engage. He can refuse our terms. He can run, reposition, attack again. We cannot run. We cannot reposition. We can only hope he makes mistakes. He looked at the Hellcat, sitting silent on the tarmac. This aircraft is not our only problem. It is the combination of the aircraft, the training, the tactics, and the industrial capacity. They produce these in thousands. We produce Zeros in hundreds. They train their pilots for 300 hours. We train ours for 100. They have radar to position their fighters perfectly. We have eyesight. Nakajima opened his notebook to the final page. My recommendation: immediately revise all tactical doctrine. Stop teaching pilots to dogfight. Start teaching them to survive. The age of the turning fight is over. The Americans ended it. The Hellcat proved it. The report Nakajima sent to Combined Fleet Headquarters that evening was classified top secret. It would take 3 months to reach Tokyo. By then, the recommendations would be irrelevant. The Marianas Turkey shoot would happen in 9 days, the massacre at Leyte Gulf in 3 months. The collapse of Japanese naval aviation was already inevitable. The captured Hellcat had revealed its secrets. But knowing the truth could not change it. July 15th, 1944, Aslito Airfield. The captured Hellcat sat in a heavily guarded revetment while Lieutenant Commander Nakajima prepared for the most important test, comparative gunnery trials. Captain Shiga had authorized a series of exercises that would pit the Hellcat's weapons system against Japanese armament in controlled conditions. The test would be simple. Both aircraft would make firing passes on a target at ranges from 100 to 400 meters. Time to hit, ammunition expenditure, and target damage would be measured and compared. For the Japanese side, Warrant Officer Hiroyoshi Nakanishi would fly a Zero Model 52, the most current production variant with improved firepower. The target was a war-weary C-5M Babs reconnaissance aircraft, irreparable but structurally intact, anchored on the beach with cables. Technical teams had installed pressure sensors throughout the airframe to measure bullet impacts. Each sensor would record the location, time, and approximate energy of any hit. Nakanishi would fire first. At 0700 hours, he took off in 043 to 188 and climbed to 5,000 feet. The Zero's armament was standard for 1,944, 2 7.7 millimeters, Type 97 machine guns with 680 rounds each in the nose, 2 20 millimeters Type 99 cannon with 100 rounds each in the wings. Beginning first pass, 300 meters, dead astern, Nakanishi radioed. He rolled into a shallow dive, the target Babs growing in his gunsight. At 300 meters, he centered the illuminated pipper and pressed the trigger. The two 7.7 millimeters guns fired first, their tracers reaching out. At 250 meters, he added the 20 millimeters cannon. The combined fire poured into the Babs for approximately 2 seconds before Nakanishi broke off to avoid collision. He pulled up sharply and climbed back to altitude. First pass complete. Observed multiple hits. On the ground, technical teams swarmed the target. The results were recorded methodically. 11 7.7 millimeters hits, 3 20 millimeters impacts, total time firing, 2.2 seconds. Ammunition expended, approximately 30 rounds of 7.7 millimeters, 6 rounds of 20 millimeters. The 7.7 millimeters bullets had punched through the Babs's thin aluminum skin, but lacked penetrating power. Most holes were simple punctures. The 20 millimeters shells had done severe damage. One had shattered a wing spar, another had torn through the fuselage, a third had detonated in the tail section. The 20 millimeters cannon provide lethal damage, observed Lieutenant Hiroshi Matsumoto, the armament specialist, But the rate of fire is slow and accuracy is poor. The 7.7mm guns provide better accuracy but inadequate destructive power. Nakanishi made 5 more passes at various ranges. The results showed consistent patterns. At 400 meters, hit probability was approximately 15%. At 200 meters, hit probability increased to 40%. Below 150 meters, hit probability exceeded 60% but put the attacking aircraft at severe risk from debris. Zero gunnery complete, Matsumoto announced. Total rounds fired: 287 rounds, 7.7mm, 54 rounds, 20mm. Total hits: 63, 7.7mm, 12, 20mm. Hit percentage: 22% for machine guns, 22% for cannon. Target damage assessment: moderate. Structural integrity compromised in 3 locations. Fuel system penetrated in 2 locations. Control surfaces damaged but operational. The technical teams replaced damaged sections of the BABs and reset the sensors. At 0900 hours, Nakajima took off in the Hellcat. The difference began before the first trigger pull. The Hellcat's gunsight was gyroscopic, automatically computing deflection for turns and dives. The Zero's gunsight was simple optics the pilot had to estimate lead manually. The Hellcat's sight had a range dial that adjusted the illuminated reticle for target distance. The Zero's sight was fixed. Beginning first pass, 300 meters, dead astern, Nakajima reported. He rolled into the same attack profile Nakanishi had flown. But the Hellcat's dive was faster, more controlled. At 300 meters, Nakajima pressed the trigger. The 6 50-caliber machine guns fired simultaneously. The sound, even muffled by the engine, was like tearing canvas. The tracers every 5th round created visible streams converging on the target. Nakajima held the trigger for exactly 2 seconds, the standard American burst duration, then broke away. The technical team's preliminary assessment came immediately, requesting confirmation. Sensors showing 47 impacts. 47 impacts, 2-second burst, Matsumoto repeated, disbelief in his voice. That's impossible. But it wasn't impossible. When they examined the BABs, the damage was catastrophic. The 50-caliber rounds hadn't simply punctured the airframe, they had shredded it. Holes the size of a fist marked where bullets had entered. Exit holes were even larger, the bullets tumbling after penetration. The concentration of fire had struck a 6-foot circle on the BAB's fuselage. Within that circle, the aluminum skin was gone, replaced by a ragged opening. Stringers were severed, ribs were shattered. 1 bullet had struck the main spar and cracked it. 1 burst from the Hellcat has done more damage than 6 passes by the Zero, Matsumoto stated. This is not a linear increase in firepower. This is exponential. Nakajima made his second pass from 400 meters. 2-second burst. Result: 32 hits. The third pass from 200 meters, 54 hits. The fourth, from 150 meters, 61 hits. The hit density is incomprehensible, Matsumoto reported. At 200 meters, the Hellcat is placing 54 rounds on target in 2 seconds. The Zero places 8 rounds in the same time at the same range. The Hellcat delivers 675% more hits per unit time. But the number of hits was only part of the story. The destructive power of each hit dwarfed Japanese weapons. Lieutenant Kenji Yamada, a structural engineer, analyzed the damage. A 7.7mm bullet carries approximately 800 joules of energy, he explained. A 20mm shell carries approximately 9,000 joules, but most of that energy is explosive, not kinetic. A 50-caliber bullet carries 18,000 joules, all kinetic. He pointed to the damage pattern. The 50 caliber doesn't just penetrate, it destroys. The bullet impact creates a shock wave that propagates through the structure. Rivets pop out adjacent to the impact point. Panels crack. The cumulative damage from multiple hits doesn't add, it multiplies. They conducted structural tests. A section of the Bab's wing was placed in a test fixture. A single 20mm shell was detonated against it. The shell punched through the skin and exploded, creating a 300mm diameter hole, significant but localized. Then they fired 3 .50 caliber rounds at another identical section, spacing them 150mm apart. The result was unexpected. The 3 holes merged into a single failure. The panel simply collapsed, the combined structural damage exceeding the material's ability to maintain integrity. This explains the combat reports, Captain Shiga observed. Our pilots report that Zeros hit by Hellcat fire disintegrate. Not catch fire, not lose control, disintegrate. The structural damage from multiple .50 caliber impacts exceeds the airframe's ultimate strength. The ammunition capacity test came next. Nakanishi took off again in the Zero with full ammunition. 1,360 rounds of 7.7mm, 200 rounds of 20mm. Using standard 2-second bursts, he made firing passes until the guns were empty. The 7.7mm guns emptied after 31 bursts. The 20mm cannon emptied after 15 bursts. Total engagement time, approximately 92 seconds of firing across multiple attacks. Nakajima took off in the Hellcat with standard combat load, 2,400 rounds total, 400 per gun. Using the same 2-second bursts, he continued until empty. The Hellcat's ammunition lasted for 64 bursts. Each burst delivered 6 times the projectiles of the Zero's burst. Total engagement time, 128 seconds. The Hellcat can engage 8 separate targets with full burst duration before requiring rearmament, Matsumoto calculated. The Zero can engage 2 targets with cannon, 3 with machine guns. In a multi-plane engagement, the Hellcat pilot can continue fighting after the Zero pilot has expended all ammunition. The rate of fire demonstration was even more revealing. They filmed both aircraft firing at high-speed cameras, capturing 120 frames per second. The footage showed the mechanical differences starkly. The Zero's 7.7mm, Type 97 guns fired at 900 rounds per minute. But they weren't synchronized. One gun fired slightly faster than the other. The result was a wavering stream of tracers that made aiming difficult at long range. The Zero's 20mm Type 99 cannon fired at 550 rounds per minute. The mechanism was complex, prone to jamming, and the recoil was asymmetric. If one cannon fired and the other didn't, a common malfunction, the recoil yawed the aircraft unpredictably. The Hellcat's 6 Browning M2s fired at exactly 750 rounds per minute each. The synchronization was perfect. The high-speed footage showed all 6 guns firing in unison, the tracers creating perfectly parallel streams that converged at the harmonization point. The reliability is the decisive factor, concluded Matsumoto. We examined the Hellcat's guns after firing 2,400 rounds. No malfunctions, no jams, minimal wear. The Browning M2 is designed for 100,000 rounds before overhaul. Our Type 99 requires maintenance every 2,000 rounds. They conducted deflection shooting tests. Both aircraft would make passes on a target towed behind a truck at various angles, 30 degrees, 45 degrees, 60 degrees off-bore. Nakanishi, an expert marksman with over 400 combat hours, managed hit rates of 18% at 30 degrees deflection, 9% at 45 degrees, and essentially 0 at 60 degrees. The manual computation of lead, the varying ballistics of 7.7mm versus 20mm, and the asymmetric recoil made deflection shooting extraordinarily difficult. Nakajima, with no Hellcat experience beyond 2 hours of familiarization, achieved 32% at 30 degrees, 24% at 45 degrees, and 11% at 60 degrees. The gyroscopic gunsight computed the deflection automatically. The pilot simply placed the illuminated reticle on the target and fired. The uniform ballistics of 6 identical guns eliminated the need to compensate for different trajectories. An average pilot in a Hellcat outguns an expert pilot in a Zero, Shiga summarized. The weapons system compensates for pilot skill, or rather, it amplifies basic competence into expert performance. The final test was the most damning. They anchored a Zero Model 52 next to the Babs target, a complete, operational aircraft that had been damaged beyond economical repair. The test. How many passes would it take each aircraft to destroy the other? Nakanishi attacked the Hellcat first. He made 6 firing passes, expending 520 rounds of 7.7 mm and 68 rounds of 20 mm. The Hellcat absorbed the damage. The armor plate stopped 7.7 mm rounds completely. The 20 mm shells did more damage. One punched through the cowling, another shattered the canopy, a third holed a wing, but none struck a critical system. The self-sealing fuel tanks sealed automatically. The redundant control runs meant cable damage didn't compromise flight controls. Hellcat remains flyable after 6 attack passes, Matsumoto reported. Approximately 40% of ammunition capacity expended by attacker. Defending aircraft has sustained damage but remains combat capable. Nakajima's turn. He made a single pass. 2-second burst. 53. 50 caliber impacts on the Zero. The Zero didn't just become unflyable, it ceased to be an aircraft. The fuselage split open, the tail separated, the left wing folded up, the engine cowling tore away. Fuel poured from ruptured tanks and ignited. When the technical team approached with fire extinguishers, they found nothing worth saving. Zero completely destroyed, single attack pass, Matsumoto stated. 4% of ammunition capacity expended by attacker. The silence that followed was profound. Every pilot present understood what the test had proven. In any engagement, the Hellcat could destroy a Zero faster than a Zero could seriously damage a Hellcat. The exchange ratio wasn't just favorable, it was asymmetric to the point of inevitability. Nakajima's final report to Combined Fleet Headquarters pulled no punches. The F6F Hellcat's armament superiority is absolute, and cannot be countered by tactical innovation or pilot skill. The combination of 6 50 caliber machine guns, 2,400 round capacity, gyroscopic gunsight, and structural protection creates a weapons system that dominates all Japanese fighters completely. A single Hellcat carries more destructive power than 3 Zeros combined. It can engage longer, hit more accurately, and survive return fire that would destroy our aircraft instantly. The American pilot does not need to be an expert marksman. The weapons system makes him one. Our armament doctrine prioritizes the maneuverability that allows a skilled pilot to achieve the perfect shooting position. The Hellcat armament doctrine recognizes that perfect positions are rare in combat and provides overwhelming firepower that makes imperfect positions lethal. Most critically, the Hellcat's ammunition capacity allows sustained combat. Our pilots must disengage after brief fighting to conserve ammunition. American pilots can remain engaged indefinitely. In squadron versus squadron combat, this difference is decisive. There is no remedy for this disparity within our current industrial capacity. We cannot produce 6-gun fighters. We cannot produce 50 caliber weapons in quantity. We cannot produce gyroscopic gunsights. We cannot upgrade our ammunition load without redesigning the entire airframe. The Americans have not just designed a better weapon, they have designed a weapon system we cannot duplicate and cannot counter. The war in the air is effectively decided. The captured Hellcat was destroyed by American bombing 3 weeks later, but the truth it revealed could not be destroyed. The 50 caliber machine guns had rewritten the mathematics of aerial warfare. Japanese fighters, designed around dogfighting philosophy, could not survive in a combat environment where overwhelming firepower replaced maneuver. Every Japanese pilot who flew against Hellcats after Saipan was fighting not an enemy but an execution. The Hellcat didn't outfight them, it simply shot them down with industrial efficiency. The test flights at Aslito Airfield had proven what combat had already suggested. The era of the dogfight was over. The era of the gun platform had arrived, and Japan had brought bamboo spears to a machine gun war.